Hello and welcome to this video. My name is Robert Carlton, and in this video I present an overview to contaminant identification and present the plan for the future videos on this subject. In this video I'll talk a bit about an introduction to contaminants, something about the identification strategy, and I also give you a list of the common types of contaminants that I'll be discussing. In this video, I'll discuss a bit about why contamination analysis, contaminant identification is important. Of course, the sources are pretty much everywhere. And oftentimes in industry, I've encountered the attitude that says, well, if we run our manufacturing process well, should we even get contaminants? And while that's kind of theoretically true, it seems to me that in fact it's a bit naive that we are going to get some contaminants because the stray particles are so common, and so we need to have a way. I would think we would have a way to deal with it. In many companies I've been with, in fact, we don't, and so it was kind of a mix of different people doing different things, and a new process every single time that we did it. In any case, this video was less about that process with regard to the larger corporation and more about, well, how do you do this if in fact you do need to do a contaminant analysis. The first point is microscopy really is ideally suited to contaminant analysis, and in fact, in some cases, it's the only tool. If you have a biological specimen, if you have pollen or you have something of that sort, the only way that you can really truly identify that is with microscopy. And I think this is one of the ways that the microscopist can have a real direct impact and effect on the success of the larger organization. Once again, the guiding principles are success in contaminant identification is very much related to your skill as an analyst, as a user of the microscope. Now, you can get that skill a lot of different ways, and begin to get that skill in a lot of different ways: watching videos, reading books, going to meetings and listen to people talk about the subject. But in the end, you're going to have to sit down in front of the microscope and do some work. And what I'm hoping with these videos is that I can give you some tricks, some little operating things that I've learned over the years that will help you do the job. The other thing is you have to be able to sample well, and with contaminant identification, it's just crucial that you do good sampling, and that's not a trivial subject at all. And I'm going to try to cover that in some detail in these upcoming videos. This is a little busy as a slide, but what I'm trying to get at here is this general classification of contaminants and the utility of having a scheme that separates contaminants based on what you think the source is. Now, of course, you're going to have to do some identification exactly before you get the source. But the USP, the United States Pharmacopoeia, General Chapter 1787, Parenterals and Ophthalmics, has a really nice program for the classification of contaminants. Extrinsic being outside of your process, intrinsic being part of the process, inherent being part of formulation, as we call it with pharmaceuticals, but part of whatever it is that you're making. So the classification of this type can typically be done reasonably quickly before you do, in some cases, before you do your verification of what the identification is. And this can be really helpful for those people who are who have the responsibility of figuring out what the problem is that caused the contaminant and how to fix it. I recommend that you look this up. There's a lot of information on the web about this classification scheme. In microscopy in general, it's not that useful to have recipes or formulas for how to do work. Typically, the work is uncommon enough or different enough one project to the next that it's kind of difficult to do that with any degree of confidence in what you're doing. However, with contamination identification, I actually take a different viewpoint. I do, in fact, think that a strategy that you fairly rigorously follow is a useful thing to do. And I believe that if you follow this strategy, for instance, if you begin with a visual examination, and I do mean visual, you just simply take a look at whatever material has been presented to you that has the contaminant in it and take a look at it. Take a few minutes to take a look at it. Get your history, get your provenance. Where did this come from? Who's had anything to do with it? And then you begin really the analytical part of the work with stereo microscopy. And with this, you begin to develop, first of all, your initial hypothesis. What do you think this is? Does this look like a bit of metal? Does it look like a glass? Is it appear to be a polymeric fiber? And then you go through the rest of this scheme to attempt to nail down what the answer is, what the identification is. I'm going to try to attach some of these slides like this to the description and to the comments. So far, I've not had a great deal of success with that with YouTube, but I'm going to try. If not, I'm going to have these things available for you to take a look at using my website, which is carltonmicroscopy.com. As a side note, a personal rule of thumb that I use is that I get different degrees of confidence if I have multiple tests with different scientific operating principles that are all in agreement with each other about the identification. And I begin with, if I have one test that suggests that it's this, then I have relatively low confidence that that's what it is. If I'm just looking on a microscope image and I see what looks like a cellulose fiber, I have pretty much a low degree of confidence. Now, if I do a second test using a different principle, maybe I'm using polarized light, probably I'm using something like infrared spectroscopy, then I have medium confidence in the result. If I can get 3 tests, and that's not always possible, if I'm looking at the biologicals, for instance, probably 1 test is about as good as I can get. But if I can get 3 tests that with different scientific principles that are all in agreement, then I have a very high confidence in the identification. What do we use with regard to microscopy for this? Optical microscopy, polarized light microscopy, vibrational microspectroscopy, infrared and Raman, scanning electron microscopy with energy dispersive X-ray spectrometry. All of these are the tools that I use on a regular basis, and I don't generally need too many other tools. Possibly a solubility test might be called for. I have used solid state NMR before, and that's worked reasonably well. There's a whole host of microchemical tests that can be used. Thermal microscopy may be useful. Now, all of these things can be helpful, but in fact, the workhorses are the 4 or 5, depending on how you want to count it, techniques that I've listed here. How am I conducting these videos? Well, they're divided between common types of contaminants and then techniques for identification. And the videos of the common contaminants showing you how to apply the tests that you would use, say with polarized light microscopy, assume that you know how to use the instrument. The technique videos, on the other hand, directly discuss how to use the instruments, and hopefully are teaching you reasonably well how to use it. Although that's a bit difficult because that is to some degree instrument specific, and I can't obviously do every instrument. In any case, all of the videos are separated into different playlists. Now, the following slides, again, something I hope I can get into either my website soon or that I can attach in some fashion to the comments or the description of this video. The common contaminants that I have encountered, I've listed in the following slides, and I'm going to use these materials to illustrate how to use the microscope, and I really would like to go through all of them, although that might be a bit of a challenge. One reason I have this here is that I think if you can readily identify these materials, then you are well prepared to conduct real analyses, and they're good samples to practice with. Fibers are one of the most common contaminants that you're going to come in contact with. Here's a list of the ones that have been the most common in my experience: cellulose, nylon, polyester, hair, human hair, plant trichomes. All of these are very common. And in general, it's PLM, IR, and Raman. Flakes and crystals are also very common. Glass, polymer, inorganic and organic flakes and crystals. All of these things are reasonably common. Obviously, glass and polymer are very common. Metals, you really need to know how to do metals, and primarily that's SEM EDS. And that's one where there aren't really too many other things you can do that are going to be for aluminum, for instance. And if you get a nice peak for aluminum with energy dispersive X-ray spectrometry, I think you're reasonably confident that that's what it is. Polymers, little bits of polymers in any form: polyethylene, polypropylene, polystyrene, PVC, Teflon. All of these are very common. Rubber, elastomer. Elastomers are not uncommon at all as contaminants. There's miscellaneous carbon black, both carbon black and charred material, stuff that's been burnt. Boy, these are really difficult to analyze because in general there's not good positive tests for them. Nearly always you have to look at it and say, I recognize this, and I've done all the testing, and by elimination I've concluded that it's something like carbon black. Lubricating oil is very common. If you're dealing with parenterals in the pharmaceutical industry, protein aggregates. And then there's biological. And with the biological, this can be extremely difficult because it requires that we be an anatomist almost in order to understand and recognize all of these things. But you can recognize reasonably well that this is a biological material as opposed to being a plastic material or a metal material. So that was a lot of information, and I went well over the time that I planned for these, but I thought laying the groundwork for this type of work was worth spending an extra couple of minutes. And I plan to reinforce these ideas as we go through the subject of contaminant identification. And my textbook on pharmaceutical microscopy, I devote an entire chapter to the subject. The web has a lot of information. So in the next set of videos, I'm going to be looking at fiber identification. And as I said, I hope to cover most of the common fibers.